Welcome back. So this is a bit different from a game. This is in fact a Raymarch SDF editor of a sorts. So I won't go into too much detail about what Raymarching or SDFs are. There are plenty of better resources out there, especially Inigo Quiles. I hope I pronounced his name right. But effectively, this is a subset of like ray tracing, and there is no mesh geometry here. It's all representations of surfaces using maths to define how close you are to a surface, which is where the sign distance field of SDF comes from. So all of this is effectively procedurally done. You can affect, this. The size of this hexagon prism, hex prism, and the benefit is being able to do these sorts of things here, where we've got this sort of complex concave cutout of the box and sphere have been unioned into one shape, and then we are subtracting this hexagon from it. But we could change this hexagon into a different shape, this octahedron. And it kind of works. You get this. I've still got weird banding in the shadows, but that's okay. I mean, for this, you can do a nice big. You got this torus cutout. It's going green and brown because the green light is actually at position 0. If I move that over, kind of need a good way to visualize exactly where the green light is. But if I move it over to the side, so we got the shadow over here. We can then make some of this a bit smaller, and you can see some of you can probably see the green lights over here somewhere. But yeah, so I've got a few different like lighting models for some of these things, mostly for debugging really. But yeah, so really this was just a way to practice and sort of start to get an understanding of how all this worked. Like my initial version was all written in just plain JavaScript, and then I learned a bit about workers to try to multi-thread rendering straight to a canvas, and it was easier to debug than shader code, but it was definitely way slower. And then my second version, I tried to create like this whole virtual machine, a stack to do all the operations, pushing onto it like a stack in the shader, and then sort of figuring out what you had to do at every step, which technically worked. It was basically the giant calculator done in shader code, and it did technically work, but it was still quite slow. And this final version is done using let's put in some more background stuff. This version is done where I create a scene from here, and I actually generate the SDF shader here in one big one big long line here. So it's not the easiest to debug. I usually debug straight in the console, but here we can kind of see that like I just output some shader code, and then I recompile the shader to suit the new scene. But there are a bunch of parameters here for like rotations and offsets, so that let's like rotate this. That's done in degrees. And if I can rotate this donut here, and I don't have to recompile the shader. I just have to update the parameters. But if I want to actually change the types of shapes and operations, then you have to recompile the shader. Sort of a balance in between the two, rather than having it hard code in every single thing. But yeah, so it's worked out pretty well. I could do some repetition for this as well. Get some donuts going throughout the scene. Again, I know this is probably all looking a little abstract, but I feel like I've learned a lot about all this sort of stuff. And I'm happy to leave it at this point. Again, you can play around with it if you want. There is a very limited way to like save and load a scene and see what the raw JavaScript is. JSON representation for the scene is. Got a few different tools for like trying out looking at the scene in different ways. And probably the most interesting thing is being able to represent fractals as well. So we've got a Mandelbulb here, which is like a 3D representation of the Mandelbrot fractal, and you can just kind of do that, and you can just make an operation that interacts with that, And it's all, there's no mesh generation here. Don't have to figure out complex things. Let's turn this back into a hex prism. I can just do a cutout from this. Let's put the green light back in the middle so you can see the cutout. Yeah. So you can just do a cutout of this fractal here, and like it is still computationally expensive, but like it's also a lot simpler to do than trying to do this using a mesh. So yeah, this is what I was working on. Ideally, I wanted to try to figure out if I could turn this into some sort of like game rendering engine for doing like, if I wanted to have it that you could create a spaceship, because of course, have a cylinder here and then like taper the cylinder in some way, and then you can create like a saucer section for a ship that looks maybe something similar to a Star Trek ship. And then you'd just get like, a perfectly smooth cylinder, and you wouldn't have to worry about level of detail from things where it's like you want to be up close, right up against the, walking on top of a spaceship and then really far away. But I don't think I'm quite technically, I don't know enough about all this to really create a game engine in this. So it was just a test to see how all this stuff works. But I did make something with it in Godot, which was much smaller. I'll show you that now. So this is what I've been working on. This is a standalone Galaxy Map done in a pixel art style that's actually rendering at 480 by 270, and then just integer scaled up to 1080p. And you might be wondering how the SDF stuff comes into play here, because this is actually a vector graphic, and these little stars here are all just pixel art that I made in a sprite. The SDFs come into play with these visualizations of these individual planets. So this is just some sci-fi world building project. Again, not for anything particularly real. I also did not make the music, by the way. But yeah, I just pulled from different things that I liked. Earthrathia is a reference to Erathia from Heroes of Might and Magic. This planet over here, Thunder's Rest, is a reference to Space Strife. Even added in some little flashes of lightning that's supposed to go off on here. But yeah, so all of this, so the SDFs are all these different things here, which was a lot of fun to try to find a good an application for them. If I go back to this one here, like being able to have something where I can just sort of procedurally generate some clouds around this planet. I made the waves very subtle, but they are there. Another reason to do SDFs was that it was very easy and straightforward to fully control the color palette, because there's no existing lighting model. I have full control over every pixel. It was very easy to create a texture palette so that it would have a much more limited gradient. Especially for things like when the shadows of these clouds go over, I can control that like it should look this blue when it goes over the water, and this green or this orange when it goes over the land. And having full control over that was very good. I know it's not the only way of doing that. I could probably have figured out a way to create a palletized post-process thing for some traditional rendering. But to prove that this is also just fully SDF rendered, is I can affect some of the noise on here. Noise scale, there we go. You can kind of see that like you end up with some weird shapes going into weird parts of the palette when you really expand upon the thing. But this isn't the clouds are still down there. Thanks. One of these should, there we go. It's a little hard to read some of these things are. I can't quite see now. But yeah, so like this is not just like a sphere that I'm projecting a Perlin noise like terrain onto. This is like an individual distance to the edge of some shape, and that shape is starting off as a sphere and then being manipulated by the noise. When I'm also using that noise to figure out what the color should be at each level. So let's make that noise scale a bit smaller again. Actually, you know what? It just resets whenever you open and close it again. This wireframe is also just an OBJ file, which I exported from Blender. I just made a bunch of low poly shapes, exported them as OBJ, and then I used some software rendering to kind of give myself full control over how the wireframe rendered. I did initially try to do some like hand-drawn pixel art wireframe stuff, but it was really hard to get right, especially when I wanted to make everything fully interactable, like with this black hole. I did not make this black hole, by the way. This is one that I ended up copying more or less straight from Shader Toy. Which again, the full source and credits can be found at GitHub. I did adapt it to fit into the rest of my scene and all of that, but yeah, the original shader was very good. And also, all of this is controlled from one shader that's just got a bunch of parameters that are being changed. Some of them are regular shader values that I can change from here, some are some other ones. So I can say, what would this black hole texture look like, but on the planet scene? It doesn't necessarily look all that interesting, because I kind of tweaked each texture to fit the mold. This is what Thunder's Rest would potentially look like. Is Thunder's Rest number 1 or is it number... No. Anyway. So yeah, there's quite a few different scenes in here. And that one. And then I forget where they all are. Especially it doesn't help with this galaxy. It keeps rotating. Where is it? Well, this one's pretty good. I like this one. Donut, torus-shaped planet. I did want to kind of make it so that some of this, there was some more mountains in the middle, because I feel like that's where there would be more mountainous. I made a ring world, which was very fun. So yeah, anyway, I had a lot of fun learning all this stuff. Yeah, anyway, if you hope you found some of that interesting. I am intending to go back to Space Strife after this to sort of wrap that project up. There probably won't be a lot of new content, but there will be a release. And I'm not intending to release it on Steam anymore. This doesn't feel... It's not the right project for that, and I'm happy with where I've gotten it to, though. I've learned a lot from doing it. So, anyway. Yeah. Anyway, see you in the next devlog, which will probably be back to being a regular game, and not just like a game element. Alright, bye.